Okay, in this video, we're going to continue working with complex numbers. We're going to look at the powers of I, how to graph complex numbers, and how to add and subtract complex numbers. So let's get started. Okay, in the previous video, I mentioned that I is the square root of -1, and we write it as an italicized I. We also state that I squared equals -1. It just is. You have to accept that. Now, I cubed is I times I squared. So since I squared is -1, then we get I times -1, or I cubed equals -I. I to the fourth, think of that as I squared times I squared, and this gives you -1 times -1, which is 1. So I to the fourth equals 1. And if we look at I to the fifth, we'll think of that as I times I to the fourth. I to the fourth is 1, so then I to the fifth is the same as I. I to the sixth is I to the fourth times I squared. I to the fourth is 1, so this is 1 times I squared. So I to the sixth is simply I squared, which is -1. And if we continue with other powers, let's say like we're going to look at, let's say I to the ninth. We want I to the ninth. We can think of that as I to the fourth times I to the fourth times I. We look at the exponents. That's 4. That's 4. And 4 is 8. Plus 1 is 9. So this gives us 1. This is 1. And here's I. So I to the ninth is the same as I. And if we realize that when we break it up into I to the fourths, we're looking really at the remainder. So if you were to take I to the ninth, divide it by 4, then 9 divided by 4 has a remainder of 1, and so the remainder of 1 is the I. And that's how we can work with the powers of I. Now, we saw in the previous video, in the introduction, that when we have a quadratic that doesn't cross the x-axis, we don't have any real roots. We have imaginary roots. And so when we want to actually graph an imaginary or a complex number, we can't graph it on the real coordinate plane, which is the xy coordinate plane that we're most familiar with. But we can graph it if we change our coordinate plane so that we have, instead of the x, we're going to call this the real coordinate, the real values, and over here is going to be the imaginary axis. Okay, so instead of it being x and y, we have our real axis and we have an imaginary axis. Now, when we have a complex number, then we're going to have, let's say, a number like 2 plus 3i. So a number like 2 plus 3i tells us we're going to go over 2 on the real axis and up 3 on the imaginary axis. So right here is the number, and we write it like this, 2 plus 3i. We always put the real part first. So that's how we would graph the 2 plus 3i. Our real number and then our imaginary number. If we wanted to graph the number 2, we would just go over 2. If we had just the number, let's say like 5i, we would count up 5. 1, 2, 3, 4, 5, and this is just the number 5 I. It doesn't have any real part, so it's just along the imaginary axis. If we wanted to graph the number -3, -2, we'd go -3, -1, 2, 3, -2. And this is the point -3 minus 2i. So it feels very much like graphing along the xy coordinate plane, except our numbers are written different. Okay, we have the real part first, and then either plus or minus the imaginary part. This number right here, I forgot to write it. It's just the number 2. It's just the real number 2. If it's just an imaginary number and doesn't have a real part, it's going to be along the imaginary axis. And otherwise, it's going to be graphed very much like the xy coordinate plane, except we have the real numbers. We go to the real part first, and then plus or minus the imaginary part. And that's how we graph on the complex coordinate plane. Okay, now let's look at adding complex numbers. So we have the complex number 2 plus 5i, and we're going to add it to 1 plus 3i. So we can see that we don't actually need the parentheses, but we're going to add our like terms, and we see we have a 2 and a 1. That's the real part, so we add those together, and we get 3 plus, and we have 5i and 3i, and we add that together, and we get 8i. So it's very much like regular adding binomials. We're going to add the like terms. If we have, let's say we have 4 minus 2i plus -1 plus 7i. Okay, again, we're going to add our like terms. So we have 4 and a -1, which gives us 3. And we have, I think of this instead of minus as plus a negative. So I have -2i and 7i, and that gives me 5i. So when we add our two complex numbers, we just add our like terms. Now let's suppose we're going to subtract a complex number. So if our first complex number is 2 plus 7i, then we're going to subtract the complex number 3 plus 5i. Then what we're going to do is instead of subtracting or multiply through by the negative, I'm going to change the signs here. And so now I have, for my like terms, I have 2 and -3. And so this gives me -1. And then I have 7i and -5i, and that gives me plus 2i. So we just go ahead and we distribute the negative, and then we combine like terms. And that's how we subtract complex numbers. When we add complex numbers, we just combine the like terms. So it feels very much like when you worked with binomials. And that's how we add and subtract complex numbers. We'll look at multiplication and division in the next video. Hope this helps.